Stand by in 3, 2.
Is the pizza here? Well, good afternoon. I'm Ron Sauer, normally hosting my own show, but today it's
his lucky day. It's his lucky day.
Yeah, my lucky day. The show is called Barry, The Price is Right Architect Show, or something like that. And what I'm hoping Barry can tell us about is...
and I haven't seen these questions.
Yeah, this is never before seen stuff. What does it mean to have a sustainable home?
Well, let's start briefly with what it means to be sustainable.
All right.
So what that really means is meeting our present day needs, but not impeding the ability to thrive in the future. That has both implications for a homeowner, and it has implications for the community and the environment. So you're looking to make choices that are going to make your life easy, make you comfortable, make your house durable, but also being mindful of how that's going to be to manage in the future, both personally for your family, whoever owns the house in the future, and the community where the house belongs.
So the second question is, what is a passive house?
The short definition of a passive house is a house that really seeks to reduce how much energy it takes to run and operate a house. Okay? What you're trying to do is minimize how much energy is required to heat and cool the home. So that's achieved mostly by insulation.
Sure.
It's achieved with being mindful of how a structure is made, so you have as few paths as possible for air to find its way into the building. And then there's a variety of other things that include balanced heating and cooling loads. You want to be thoughtful about your position so you maximize the use of the sun but not have too much sun. There's a lot of balancing involved, but generally speaking, you're really trying to reduce the amount of energy that it takes to run the house. In this climate, what you're really looking for is having the maximum amount of interior volume with the minimum amount of exterior surface, right? So if you think about a salt box or a barn or a very simple form,
sure,
those are the buildings that are the most straightforward to make comfortable and to perform at a very high level. Any house in any form can be brought to the passive house standard or to a high performance standard. But the more transitions, the more complexity in the form, the more difficult it is to do.
Sure.
The elephant in the room is carbon. What all of this is about carbon sequestration. The quickest way for us to get a handle on carbon levels and temperature increases is to maximize how much carbon we're sequestering. And what that really means is using wood. Wood is the short-term answer, because all this wood sitting here, all this wood that's sitting here is holding carbon. It's a bank, right? And every bit of it that we don't burn or allow to decompose or decay, we're keeping it from heading back out into the atmosphere. Steel doesn't do that, concrete doesn't do that, vinyl doesn't do that, cement board doesn't do that, wood does that. There's two debts that you have in building any building. The first is everything that it takes to get to the point that the building is finished, right?
Right.
And everything, all the energy and all of the carbon investment and all those things that add up during that process are referred to as embodied carbon. Fuel costs, milling costs, blast furnaces for steel, concrete admixtures and their manufacture. It's a lot like food, actually. We like to have food that's local, and we like to have food that's lacking preservatives, right? Building materials are very much the same way. The less you have to do to them, the less carbon debt there is in getting them to where they go, and the more they're doing what they're meant to do. Then the clock starts on operational cost and operational carbon. How much fuel are you using to be comfortable in that house, right? How many of those materials are you going to have to decommission and demolish over the life of the house to replace with something durable? For architects, for professionals, our obligation is to think about that process for sourcing, constructing, putting all the pieces together, and handing a product over. So in my work, yes, I have to use concrete, sometimes I have to use steel, but I'm going out of my way to maximize the amount of wood, whether it be structural or finishes, in my buildings, because I look at a building as a carbon bank. Which brings us here. Ron works really hard to find materials that we can source locally that may not meet standards for perfection, but meet our standards for beauty,
Right.
and that we're able to turn into some really interesting products. By directing wood that's here in the region and that we can find really good, durable, beautiful applications for, then we're solving what homeowners are interested in terms of making beautiful homes, and at the same time, in parallel, we're addressing the climate crisis.
You've got certain things that are kind of empirical and they drive things and they're very objective, but then you've got things that are subjective, like people's tastes and what
Sure.
they personally find interesting, and then you get to take all of that along with the conviction of trying to do something that's right for the planet.
It's always a balance.
And it's a difficult thing to marry all that together. It's been a pretty cool experience for me to learn from you. You know, like, I wouldn't develop that on my own.
Well, so this is an in progress, basically a conversation that we're having. So I show up one day and Ron shows me a building full of reclaimed, right, sawn lumber
Yeah.
that's been harvested regionally from old barns or whatever. In this case, it's ash, right?
Yeah.
I look around and see what he has piles of, and I ask questions. Okay, if I want to turn this into siding, what's the process? So he tells me, well, this is how we mill it. These are all the things that we need to do. It used to be that we relied on siding and roofing to protect buildings from the weather. We're really relying on siding and roofing now to protect all the substrates from ultraviolet light. All the stuff that's underneath the siding, underneath the roofing is doing all the work to keep a building dry and comfortable. It used to be that you'd be much more particular about the kinds of wood that you could use for siding. But now we're able to be a little more open, and in this case, this is diseased ash. This is all wood that would have been just trash, that would have been thrown away.
Yep.
And so because its role is really just as an ultraviolet screen for all the materials that are doing the work underneath, it can work very effectively doing that. Rather than worrying about every piece being the same width, we accept the width of each piece and you mill it, minimizing how much material that you're going to dispose of.
Yep.
You can see these imperfections, right? You can see the chatter, you can see all that, the variable width, but this is a very precise system, and this will perform at a very high level. So for me, architecturally, it's perfect.
So thanks for coming.
Oh, this is worth thanking for these
Yeah,
guys.
I'm thanking you for everything. Not
Oh, yeah.
only our friendship,
No, it's my pleasure. It's my pleasure
because the coherency and the education on how to do something right.
the more I talk about it, the more I understand it better myself.
Yeah. So thanks for coming.
You're
Thanks
welcome.
for letting me on your show.
Anytime.
Okay.